Hello, my dear grade 9 students. So, in the earlier chapter, in the earlier lesson, we discussed about several things related to the fourth lesson. Now, we are going to start a fresh new lesson here within this our fresh new lesson, the fifth lesson in your science syllabus, right? We will be discussing about the pressure acting on a certain surface. Especially, we are discussing about the pressure acting or exerted by a solid. Pressure exerted by a solid, right? Pressure exerted by a solid object. So pressure is also a kind of a factor which is created due to action of a certain force. In order to create a pressure on certain object, we have to apply forces. So as you are going further with the lesson, you will study that. Actually, the concept called pressure is created due to application of forces on a certain surface, right? So within this lesson, we'll be discussing what sort of a thing is called as a pressure. A simple introduction will be given in brief in the first place. Then after that, several things related to the pressure thing. Especially remember, we are discussing only about the pressure which are exerted on solid objects. Remember, my dear children, we are discussing about the pressure exerted on solid objects here. Okay, solids, right then. So now let's move on to see what are the main things that we are going to study about the lesson pressure. So my dear children, first of all, we'll be studying about the pressure thing, and we'll get to know what do you mean by a pressure, how does a pressure is getting created, and what kind of a like how we can define pressure. Like that way, we'll be discussing basic things related to the pressure under the first topic. Several basic things related to the pressure thing. So under the introduction of pressure, we'll be learning about the concept of pressure and how it is getting created. Then next, we'll be discussing about the factors affecting the pressure. Factors affecting the pressure. Like what kind of physical factors which is going to affect for the increasement or decreasement of pressure, right? So those are the things we'll be discussing under the effects or the factors that affects the pressure thing. So actually there are two different factors that affects the pressure. We'll be discussing about these two factors and several experiments related to these factors upon investigating these things. So we'll be discussing about the factors, essential or factors which are going to change the pressure under the factors affecting the pressure thing. Then we'll be discussing about the units of pressure. Units of pressure. So under the units of pressure, we'll be discussing how to measure this pressure. Then what kind of a quantity is called as pressure? Like we in the earlier lesson, in the fourth lesson, we studied that there are two types of quantities, like vector quantities and scalar quantities. So we'll be studying about like what kind of a thing or what kind of a quantity is pressure and how we could measure it. You know, any quantity can be measured by using a certain value, and we'll be discussing about the unit which can be used to measure the pressure thing, right? What are the units that we use to measure pressure? Then next one, change in the factors affecting the pressure as needed. So as the term goes by with the pressure, as the term goes by with the pressure, the name pressure itself is going to give you some annoying thing, right? Pressure, when I'm mentioning about the pressure, you might some might annoying, some might get, oh, pressure, it's pressure, like that way we get some kind like an annoying thing. However, if you need to change that annoying thing, that difficulty, I mean, if you want to reduce the pressure in a certain thing, right? How we can change the pressure? How we can reduce the pressure? How we can reduce that difficulty? Like that, we'll be discussing several factors. How we can change these factors for the favorableness of us, right? Like that, we'll be discussing how to change the factors which affects the pressure in order to do our works quite easy, right? Or in order to increase or decrease pressure to make our work easy, what are the factors that we can change? What are the factors that we cannot change? Like that way, we will be discussing about several things related to the pressure, several factors related to the pressure upon change in the pressure as we need. So these are the things we'll be discussing within this lesson. Then, like previous, we'll be discussing several questions at the end of the lesson. So my dear children, stay with me till the end of the lesson. We'll go through with the lesson pressure and we'll study about the pressure in detail. Right. So let's move on with the first and foremost topic in our lesson. So that is a simple brief introduction to what do you mean by pressure. So what is pressure? So here you can see two different students bearing a same bag. You can see that the bag is same. However, in A, the student in A figure, you can see that the strap here, the strap is somewhat smaller. The bag on the strap is somewhat smaller. However, the second student over here, he has a broader strap. So he's fit to go. But however, this student is struggling. He's failing with some kind of a difficulty. You can see that his shoulders are even like bent down. Okay. But however, this is okay. In the second figure, the student in here is okay. He's having no problem with that mass. Right? He can carry or lift that mass without any trouble. He's okay with it. I mean, like he can bear it without any difficulty. So let's see what has happened over here. Let's see why does the same bag, now here you can observe the same bag. Why does the same bag is going to give out a difficulty for the first person, but not that much difficulty for the second person over here. Now let's see what are the things given in here then. So you may have experienced that when the strap of your school bag is narrow means thin. Okay, broad and narrow means thin. It is uncomfortable to the shoulder. Now the person over here or the student which is in here, now why this person is struggling? Because now he has the same bag like the second person. However, the bag carries out by this person or this student has a narrow or thin strap. If the strap is very thin, my dear children, you may have observed that it's difficult to carry these masses or weights, right? You know that weight is acting downwards always. If you lift of a certain object, the weight of that object is always acting downwards because of the gravity. So my dear children, now you may have experienced that you may have experienced these things. Now you go for a shop. The shop owner gives you a shopping bag, a polythene bag, right? And all the stuff which you are going to buy from that shop has been put onto that bag. Now you are being asked to carry it out. You know that the bag, shopping bags, those polythene bags have very narrow or thin handles. So when you are carrying that bag with your handle, if the mass is somewhat high, let's imagine that you are holding about 2 to 3 kilograms. So it's very difficult to carry that bag. Sometimes when you go home and keep your stuff away, and when you look at your hand, there might be lines around your palm, right? Around your palm, there might be lines. Why is that? Because it's giving out a heavy difficulty to your hand. It's exerting a much force. Actually, it's not a force. We define that thing as a pressure. It's exerting a greater pressure to your hand so that your hand is going to wrinkle and to create several lines because of that pressure exerted by the object, right? So it's a difficulty, kind of a difficulty given out by forces upon they are having, or upon these forces are acting on a certain surface area or on a certain surface, in simple, right? So once again, I'm coming with the explanation given here. When it is broad, it is not that uncomfortable. Now you can see that when it is broad, I mean, like in the second figure, it has a broader or thicker, right? Broader or thicker strap. So in that case, my dear children, these bags can be easily lifted off, right? These bags can be easily lifted off from the place that you are going to put. Or else, now if a shopping bag or else a bag has a good broader handle, then it's quite easy to carry, but you won't feel any difficulty over there as well, right? Now in the next point is given, there are two school bags of equal weight. The shoulder strap of one of them is narrow and that of the other one is broad. Though the strap is narrow or broad, the force exerted by the weight of the school bag is same. Now this is important, my dear children. What's that? Even though the strap means this part only, these parts only, no. However, the weights are being carried out by this part. So therefore, let's imagine that this one exerting a 50 Newton of a force downward. Then if so, this one is also exerting a 50 Newton of a force downward. If we assume that both of them have the same mass, then their weights are equal. How come? Because this strap thing is not going to affect, it's not going to affect the things which are already inside the bag, or the mass of the object or the mass of these things is not going to depend on the straps, right? So therefore, their weights are also going to be equal. If they have equal masses, their weights are also going to be equal. There's no change in it. So the force exerted by the weight of the school bag is the same. So here we can say that if both of them have a same school bag with the same mass or same quantity, we can say that both of these guys are having a same weight on their shoulders. Okay, they have the same weight on their shoulders. But when the strap of it is narrow, the contact area is less, And when it is broad, that area is more. Now this is the change which is going to happen over there, my dear children. What's that change? If the strap is somewhat narrow, if the strap is thin, then it's going to contact, now on your shoulder, it's going to contact in a very simpler surface area, in a very simple surface. Your shoulder, it's like this to this much in broad, like it's this much, this to this much broad. But however, that line kind of a thing, or that line kind of a strap is acting only or it's obtaining only a very thin amount of a surface area from your shoulder. So if that strap is going to take very less amount of surface area, definitely you will feel some amount of difficulty. For a simple example, pointed part of the pen is this. I'm going to press it against my arm like this. So I feel pain. I feel hurt actually if I'm going to press it even harder. But what will happen if I'm going to change it to the opposite side? See, I can press it. Like now I can press it even more, right? But however, I can't feel that much of a pain in my arm. Why is that? Because at this side, when I'm going to press it with this side, it's exerting a greater pressure upon having lesser surface area, because the contact surface area in this part is very less, it's very tiny. So it's exerting a much difficulty, or it's giving out a good tension to the surface of my skin. So therefore, I feel a pain quite well, right? I feel a pain quite well. However, when I'm going to interchange the two terminals means at the two ends, I mean, I'm going to change the two ends. Here you can observe that this is very smooth, and also the surface area of this part is way more greater than the other. So when I'm going to press it like this, I can't feel any pain. I can feel a pain, but however, it's not that much greater as the previous case. I can like bear it, right? Earlier it was very difficult, but however, in the second time I can bear it. Not that much giving, it's not going to give out that much of a difficulty, right? It's not going to give me that much of a difficulty. Why? Because the contact surface area in this part is way more greater than this. So when I'm going to press it against my skin, it's giving out a lesser tension. It's giving out a lesser tension, right? So that's the case in here, my dear children. Even though both the school bags have the same weight or same force, the area which the force is acting is going to change when the strap is going to be broader and when the strap is going to be narrower. When the strap is somewhat narrow, it's difficult, because to bear that amount of a force, by using very thin surface area, the difficulty given out by the force would be high. The tension given out by the force would be high. That's why you feel much difficulty. But in the second case, even though the bag has the same weight as the first one, as it has broader surface area, right, the force is getting distributed. The tension is somewhat distributed around that surface area. In a broader surface area, the pressure is, or the tension is distributed. So therefore, it's easy to carry out the bag in the second place. Here the tension is distributed. Here the tension is distributed along the contact surface. So if the contact surface is less, high amount of a force or greater amount of a tension is carried out by unit area. In that case, my dear children, if the contact surface giving out a higher tension, greater tension, then the difficulty is also very high. Means the pressure is high. Right? If the same force is distributed in a larger surface area, in a greater surface area, then if you take a unit or else a simple area, then the force which is going to act or the tension which is going to act going to be very less. It's like this in simple. Let's imagine that you are carrying out a heavy load in your head. Now you might feel that this is very tough to carry. But what if this thing is going to happen now? One of your friend is going to come and help, give out a help, so that he would also come and join with you to carry that weight. Then definitely you might feel, or you feel somewhat comfortable, because that load is distributed among two different surfaces right now. Okay, it's distributed among two different surfaces, your head and the head of your friend. So in that case, the tension given out by the weight which is in your head is being distributed among two different surfaces. So therefore, you would feel a lesser tension. Lesser tension means lesser the pressure. So my dear children, if I am going to move with the explanation given in here, when the strap of it is narrow, the contact area is less. So if there is a less contact area, right, then the pressure or the tension given is very high. And when it is broader, that area is more. When it is broader, the area is greater. It has a greater area. Here you are given. Thus it is clear that though the force is the same, the pressure against the shoulder, pressure means the tension which the person is having on his shoulder, right? The pressure, the tension having against the shoulder differs with the area of contact of the strap. So it's going to change, right? It's going to change because of the, right? Because of the area, contact area of the strap of the bag. Okay, my dear children? Right. Now, again a different case. Consider two bags having the straps of the same breadth. And now in these figures, you can observe the first child has the same breadth and also the second child has the same breadth. Not in a like the earlier case, right? So consider two bags having the straps of the same breadth and different weights of books. Now here you can see that the weights are somewhat different right now. So here you can see that the bag is very loosely fit around the shoulder. But however, now this bag has a very good load. See, it has several, like the bag has this bag is very heavy. Now this child is wearing or bearing a very heavy bag. But in the earlier case, this child, he has a very less or lightweight bag. In these cases, my dear children, now in these two cases, you can see that. Now let's imagine if this person has 3 kilogram of a mass and this one has 5 kilogram of a mass. I think you could remember in the earlier lesson I told you that, right? In the earlier lesson, I gave you a simple, a relationship. How to convert kilograms into newtons. So I told you that 1 kilogram of a mass is equal to 10 newton of a force. Means this one is exerting 30 newton, while this one is going to exert 50 newton. So it's obvious to us that this child is going to bear, or it's going to have, right? He's going to have much heavier load in his shoulders. So the tension given out by the load on the shoulders is going to be very high. That's why he is feeling some kind of a difficulty. However, in the first case, this student, he is having very less load. Less load means the difficulty is also very less. So my dear children, it's obvious to us that the bag with more weight gives more press against the shoulder, right? Here, when the bag has greater mass, the weight is also going to be increased. Weight means the force is going to increase. So therefore, a greater press is given out by the bag on the shoulder. That's why this student has a difficulty in holding it. Okay. Even though it has a broader contact surface, if there is a high amount of a force acting on that surface, then the tension given out by that load, or the pressure given out by that load, is going to increase, right? So here, by considering these two effects or these two events, you can see that pressure is kind of a factor, right? Pressure is kind of a factor that's going to act on a certain surface area, and also it is contact with a force, or it is connecting with a force acting perpendicularly. Let me rephrase: perpendicularly, right? These forces are acting perpendicularly on the shoulder, right? So my dear children, the pressure concept called pressure is going to reflect, or it's going to behave with two different factors. So those two factors are the perpendicular force and the contact area of the surface, right? So my dear children, now we are going to define what do you mean by the pressure. We know that when the contact area is thin, it's giving out a good pressure, or the pressure is very high. Thin straps are very difficult to carry because it is giving out a high pressure or high tension. Broader straps are very easy to carry because they are giving out, or those things are giving very less amount of a pressure. If the mass or the load within the bag is very high, the weight is going to be increased and the force acting is also high. If it has a greater force, then my dear children, what happens? Once again, right? Once again, the pressure is going to increase. If the bag has less amount of goods, if a bag has very less amount of a mass, then the weight is also less. If it has less weight, then my dear children, you can say that easily the pressure is going to reduce and you can carry those bags quite easily. So my dear children, pressure is a concept that depends on the force acting with the contact area. Okay, it's a concept regarding with the force acting and the contact area of that particular force. Now let's see, what do you mean by the pressure. So once again here, some kind of a explanation, a brief explanation given, right? The force exerted by the weight of the school bag is distributed throughout the area of the contact. It is the distributed force that is felt by the shoulder. When the strap of the bag is broad, the force is distributed over a large area. Hence, the pressure felt by the shoulder is less. In these instances, it is useful to know the pressure exerted over a unit area. So, as I told, right, as I explained, this pressure thing or this difficulty is reflecting about the force over a unit area, unit means, what do you mean by a unit? Unit means just a one, right? Just a one single area, unit area. If the area is measured from meters, then 1 square meters of an area. If the area is measured from centimeters, then 1 square centimeters of an area. Unit means that, right? Within a unit area, how much of a force is acting? So like I said, pressure is a factor. Pressure is a factor that's going to affect with the force, okay, plus the area. So both these factors should be considered when you are going to take the thing called pressure. Okay, when you are going to take the thing called pressure, both of these factors are very important. So my dear children, remember, always the pressure or this difficulty or this tension is, right, this tension is reflecting about the force acting on a certain area. We can say it as a unit area, no problem. Right then, so we can define pressure or this difficulty in holding objects or masses like this. How come? The force exerted over a unit area is known as the pressure. Force exerted over unit area. Here especially you need to remember the perpendicular force, like this way. It should act perpendicularly on this particular surface. Now the force is acting perpendicularly. They should have a 90-degree angle like this. So directly perpendicular force should act on it. Okay. So the perpendicular force acting on unit area. Unit area means, my dear children, right, you have to take one single area, right, not whole but one. Okay, not whole but one. Here we are going to calculate if like 600 newtons is acting on 220 square centimeters, how much of a force is acting on 1 square centimeters? That's the pressure. That's what do you mean by the pressure? The force which is acting on a unit area. If 600 is acting on 20 square centimeters, how much is the force acting on 1 square centimeter? That's what do you mean by the pressure. The force which is acting or the force which is exerted over a unit area, this is the one, or this quantity is the one which is referred as the pressure. This is the quantity which is referred as the pressure, my dear children, right? So once again, pressure means it's the force acting on a unit area. Force acting on a unit area, right? Always we are finding how much of a force is acting on one bit of an area, one single area. One single area means can be square centimeters or square meters. Normally we are taking as the standard international unit of measuring area as square meters, not in centimeters, as the length is measured from meters in international standard units. So the area is measured from square meters. So basically, unit area in the sense in here is 1 square meters, not centimeters. 1 square meters. How much of a force is acting on 1 square meter? How much of a force is acting on 1 square meter is given by the concept called the pressure. So pressure is exerting, right? Or the pressure is reflecting about the force acting on 1 square meter of a surface area. The force acting on 1 square meters of a certain area. That's what do you mean by pressure, my dear children? Force acting on 1 square meter of an area. It's the one which is referred as the pressure. Right then. So always remember, when you are taking the force, this force should be perpendicular to the surface. So if the force is acting like this, then in this case also some amount of a pressure is given, but however, right, these things will not be discussed in your syllabus. We'll be discussing only about these kinds of forces which are acting perpendicular to each other. So to the contact surface, the force is acting perpendicular. Okay, these are the ones we'll be mainly discussing within this syllabus, my dear children, up to grade 11. Okay, up to grade 11. Up to your O levels, we'll be discussing about the perpendicular forces acting on a unit area. That's what do you mean by the pressure. Right then. So now we identified what is the definition for pressure. We studied that pressure is the force which is acting on a unit area in the sense 1 square meter of an area. On 1 square meter of an area, how much is the pressure, how much is the force which is going to act? That's the one which is referred as the pressure. So always this pressure concept reflects about a force that is going to act on 1 square meter of a surface area. Right, my dear children? So now we are going to investigate what are the factors that's going to affect. What are the factors that's going to affect for this tension or the pressure thing? Pressure is going to depend on, we earlier discussed that the pressure is going to depend on 2 different factors. That difficulty when that person is going to hold the bags thing. The difficulty is the thing which I have mentioned as the pressure. No? So that difficulty, right, that difficulty, my dear children, affected because of this contact surface plus area of the contact surface plus the force acting. So these are the 2 main factors, right? These are the 2 main factors that's going to affect the pressure. Already we know that, but however, we are going to investigate and I'm going to show that, prove that these are the 2 factors that affects the pressure of a certain solid object. So my dear children, by doing several activities right now, we are going to see what are the factors which is going to, right, what are the factors which is going to fx for the concept called pressure or the quantity called pressure, right? So it is given. We are going to study about the factors affecting the pressure. So this is the first activity related to it. So you'll be needing these materials. What are the materials? You'll be needing cake of soaps. Actually, we'll be needing several. So therefore, I'll mention cakes of soap. Okay, cakes of soap. Not just one, we'll be needing several, right? So I'll mention as cakes of soap, right? Cakes of soap. Then we'll be needing a string, sandbags, sandbags. Remember, each having around 10 Newton, right? Each having around 10 Newton. We'll be needing actually 4 sandbags. 4 sandbags. We'll be needing 4 sandbags. Okay, each having 10 Newton of a force or 10 Newton of a weight. You can you can measure the weight by using, right, spring balance, or else I have given you a simple relationship. You could, I think in the earlier case also I told you that 10 Newton means actually it is from mass 1 kilogram. 1 kilogram. Then we'll be needing a wooden block. Remember, when you are selecting this wooden block, it should be in the same thickness as the bar of soap. Okay. Then a stopwatch. Right, a stopwatch to calculate the time taken. So these are the ones which you need. You'll be needing cakes of soap. Okay. Then a string, 4 sandbags, wooden block, and a stopwatch. Okay. So these are the materials that you need, my dear children. Now let's see how to conduct this activity. Okay, how to conduct this activity and what is the factor which we are going to investigate in here. Okay, now let's see how to conduct the activity. Right then, so activity is given in the figure. You can see it very clearly. What you have to do, take 2 tabletops, or else you can use 2 stands. If you don't like, when I'm going to do, I'm going to use 2 stands, right? So take 2 tabletops, right? Then place the wooden plank or the wooden sheet like this. Place the cake of soap. Then you have to use that string and make a wire. Then what you have to do, you have to hang the sandbag. Then as soon as you are going to hang the sandbag, you need to calculate the time. You have to calculate the time. Okay, right then. So let's see how to do this thing. Place the cake of soap on the plank which is kept on 2 tables as shown in the figure. Okay. Hang 1 sandbag on the wire which is sent round the cake of soap. Observe what happens. Now you know that when you keep it like this and when you hang a sandbag, upon having a certain weight on the cake of soap, right, the soap bar will gradually get in bisected, or it's going to intersect by the string which is wrapped around it. Why is that? Because upon hanging this weight over here on that string, okay, on that string, what is going to happen over there is a pressure is going to exerted. A pressure is going to exert, right? A pressure is going to exert on the bar of soap. So if the pressure is exerting on the bar of soap, definitely the bar of soap will get separated, or it will get cut by the string, right? Like in the earlier times means in the past, right? Like 20 years back, there now from retail shops, my dear children, we can get half of a soap bar. We can get half of a soap bar. How could the the shop owner is going to give a half of a soap bar? He's not going to cut that soap by using a knife. He's going to use a very thin string or else a thread. So he's going to keep it like this and going to push it down. That's how the shop owner is going to cut soap into 2 equal parts. Nowadays we are not going to, or nowadays the shop owners are not going to cut it like that way and to give half and half, right? But however, in some retail shops in very rural areas, you can see it. So how the thread could be able to separate a soap bar into 2 equal parts? Because, my dear children, due to having very thin surface area, you know that the thread is having very thin surface area, or the string is having very thin surface area. So upon pressing it down the soap bar, it's going to exert a greater pressure on the bar of soap. Upon that, the bar of soap is going to be bisected by that force, as it is not enough to bear the pressure given out by the certain string or the thread. So that's how we can separate that thing or that soap bar into 2 equal parts. Here also we are going to do the same thing. We are going to hang several sandbags and we are going to cut several cakes of soap in order to observe the time taken. Okay, now first and foremost, what you have to do, you have to hang just one bag of sand like this by wrapping a wire around the cake of soap. You know that one bag is exerting 10 Newton of a force. So upon hanging the sandbag, you have to calculate the time taken. Okay, that's how the experiment is being conducted. Right, now let's go for the next step then. So hang the sandbag on the wire which is sent around the cake of soap and observe what happens. Then we are going to observe what happens. You know that the cake of soap, right, or the soap bar is going to bisect, right? However, I don't think that it's going to bisect with just one sandbag, but like up to a certain level it will bisect for sure. Not entirely, but like half or 1/4 will definitely get bisected. Okay, we'll see what's going to happen when I'm going to conduct the activity at our laboratory. Okay, then the next one, increase the number of sandbags one by one using a new cake of soap in each instance. Now my dear children, you have to use in this case then 4 different bar of soap. Remember, all of these cakes of soap should be in same size in all aspects. You need to remember that thing very well. Otherwise, the surface area would get changed. No, if the contact surface area is going to change, then the experiment will be useless. So remember to take the bar of soap which are identical to each other. They should be identical to each other, my dear children. Okay, they should be identical to each other. Okay then. So increase the number of sandbags one by one using a new cake of soap in each instance. Measure the time taken to pass the metal wire through each cake of soap and tabulate your readings. Right? So first of all, then you have to use one bag like this, then the wire, and place the setup like this. Calculate how much of a time is taken by the one bag to cut through with the cake of soap. Then remove that cake of soap, remove the bag, don't remove the bag. Take another bag and place it in the same way. But remember, this time you have to use two different bags. It's wise to use another different bag and place all of those two bags together within that bag. Then hang it over here. Okay. Then again remove those two bags. Put 3 in the bag. 3 sandbags in the bag. Right. Okay. Then remove those two soap bars. Place a new soap bar. Repeat the activity once again by placing 3 sandbags. Then calculate the time taken. Once again remove those two soap bars, okay, which has got bisected. Take a fresh one that has the same area like in the previous case. Keep it on the table as per to the figure. Use all sandbags. I told you that we have to prepare 4 sandbags too. So use all 4 sandbags and hang it. Then observe what's going to happen in the 4th instance. So remember, in each of these instances, you have to tabulate your readings by using the stopwatch. Calculate how much of a time is taken by each of these bags to bisect the cake of soap. Okay. So my dear children, this is the way of conducting the activity, right? So then finally, what do you have to do? Finally, according to this table, you have to complete the time taken, right? This is the way of conducting the activity, my dear children. According to the table, you have to fill the table. So instance 1, number of sandbags, we are going to hang 1. Then the second instance 2, in the third instance 3, and in the fourth instance 4. I told you that one sandbag should be equal to 10 Newton of a force. So in each of these instances, you'll be using 10, 20, 30 and 40. Then you have to calculate how much is the time. Okay, how much is the time? I don't think that the first one is going to intersect the cake of soap into 2 equal parts. Half or 1/4 might, but not entirely. Okay. So my dear children, this is the way of conducting the activity. Okay. Now let's head on to the laboratory and we'll conduct the activity, and let's see what kind of a thing is going to happen and which bar of soap will cut and get separated in 2 parts very quickly. So my dear children, let's head on to the lab and we'll conduct the activity, and once again we'll come back to the classroom and we'll fill out the table. Right, my dear children, now we are about to conduct this activity by using the cake of soaps. So I have arranged the setup by using that piece of string with a hook and several sandbags over here. I have a stopwatch with me to calculate the time taken to cut each of these cake of soap. First of all, now I'm going to use one bag of sand, right? And I'm going to hang it on the cake of soap very gently. Right. As I'm going to insert this thing, and when I'm releasing it, I'm going to turn on the stopwatch, right? And let's observe how much of time going to be taken by the one sandbag to cut this cake of soap, right? So here we go then. Let's start. As you can see here, now this bar of soap is getting pierced by the piece of string. So my dear children, now it's halfway through, right? It's halfway through now. Right. So my dear children, now up to like half of a distance, half of the width of the piece of cake of soap in here. Now now the string has been pierced up to like half. So right now I can't see any kind of a motion in the string. Right now I can't see any motion. Up to half of the bar of soap, the string was inserted, but when I'm observing it right now, I can't observe a clear motion. It's because that now the piercing process has stopped. So what I'm going to do is I'm going to stop the watch. Okay, so let's stop it right now. Half has been cut down, that's it, and the rest is now, right? So in the activity, when we are discussing about this activity, right, I have explained that it's not sometimes on by using only one sandbag we won't be able to cut down the soap bar, but however in here half got cut, around half, right? And it took around how much? It took around 3 minutes. So it took around 3 minutes to cut down half of the soap bar in here. Okay, half of the soap bar, to cut half of the soap bar took 3 minutes by using only one sandbag. After that, it's not getting pierced. Still you can see that the same structure, but however the string is now at a half of the level of the soap bar. It's not moving. Still it's not moving. Right. So I'm going to remove this setup now, and I'm going to replace the bar of soap using a new one. Okay, so here you can see like up to half the level, right? Up to half of the level, you can see very clearly, like up to half of the level it's been pierced down. I'm going to remove it gently. Right. Okay, now we are going for the second setup by using the second bar of soap. Now what I'm going to do here is I'm going to hang two, not just one, but two sandbags on the soap bar here. So to hang two of these sandbags, I'm going to use a polythene bag like this and insert these two sandbags like this. 1, 2. I'm going to use, now I'm going to tie a knot. Right, then my dear children, let's hang this thing on the hook over here very gently. So we'll need to increase the length of, we need to decrease the length of it. Right, so gently we'll hang this thing. So as soon as I'm going to release my hand, I'm going to turn on the clock, my timer stopwatch, to count the time taken. Oh, so here we go then, 1, 2 and 3. Right, now I'm going to stop it. I'm going to check now. Yes, almost there. Right, I'm going to stop it now. It's right. Okay. So now gently I'm going to remove the sandbags. Now let's observe the soap bar. So it's separately, you can observe the two parts over here. It's separated into two equal parts, right? So now let's count the time. Let's take the time taken. So the time taken is exactly like 2 minutes. Observe, 2 minutes. Time taken is 2 minutes. 2 sandbags, it took 2 minutes. By using one sandbag, half got through within 3 minutes. Half. We can say that actually it's not totally getting separated into two parts, right? It's not getting totally separated, but however, half got cut through within 3 minutes. Here, totally divided into two parts within 2 minutes of time period. Now, my children, let's go for the third setup where we are going to use 3 of these, right? 3 of these sandbags together. So, my dear children, the third setup. So, within this third setup, we are going to use 3 sandbags in here and a fresh new soap bar. Once again, I have with me the clock to calculate the time. Now I have prepared a setup with 3 sandbags over here. So gently now I am going to insert this thing to our string, metal string over here. Keep it like this. And now as soon as I am going to release the system, I am going to calculate the time. Here we go. Right, now it's almost there, Okay, it stopped. So I'm going to stop it now. Right. Gently now I'm going to remove this. And now let's see the soap bar. So soap bar has got separated, see, it has got separated into equal parts once again, right? So let's see the time taken. Time taken is just 9 seconds, right? 9 seconds. It's between 8 and 9. We'll assume that one as 9 seconds. Okay, 9 seconds. So within 9 seconds, it got separated into two parts. Earlier, see, it got separated into two parts within 9 seconds. When you are using one sandbag, half got through within 3 minutes of time. Two sandbags within 2 minutes of time, entirely dissected into two parts. When I'm using three sandbags, got separated into two parts, but within 9 seconds. Now let's go for the fourth setup and let's observe what's the time over there. Right, my dear children, then the fourth setup, the final setup. Here within this final setup will be hanging 4 sandbags on this piece on this bar of soap. Okay, so once again a fresh new bar of soap can be observed, same dimensions as the previous one. The stopwatch to calculate the time once again. So earlier when I was using 3 sandbags, the time calculated as 9 seconds. Now here with me I have all 4 sandbags. Gently now I am going to insert this thing onto the hook over here. So remember children, in this case the time would be very less, so we'll need to get our calculation quite fast. Right. So that's it. Got separated, right? As you can see here, it's got separated. No time to lose. See, got separated quite fast. How much is the time? Oh, you can see here the time is right now only 2 seconds. Only 2 seconds. It got only 2 seconds to cut down the piece of soap in here, right? So got separated into two, or it dissected into two parts within how much of a time? Within 2 seconds of a time period. So my dear children, it's obvious to us that when increasing the weight which is placed on the soap bar, these soap bars are getting dissected very quickly, right? They're getting dissected very quickly. So the force which is acting on the surface, when I'm going to increase that force, it's obvious to us that the pressure exerted on the object is going to increase. So let's head on to the classroom once again. We'll write down our observations and from that we'll come into a conclusion. Right, my dear children. So we conducted the activity and you could see that there is a clear difference between the times. Now let's complete the table. So in each cases we hang several or different amounts of sandbags. You know that In the third instance, we hang 3, and in the fourth, we hang 4. And you know that each sandbag weighs about 10 Newton. So, in the third instance, 30 Newton. In the fourth instance, 40 Newton. Now the time taken. So, like I said, the 10 Newton, or if I am going to hang, when I am going to hang just a one, right, just a one sandbag, there was no considerable change in it. Actually, the soap got cut, but however, only to a half. After that, it got stopped. And to cut that half, it got around 3 minutes, right? So, I'm not going to fill that thing. Already I have inserted the dash over there. But however, when I'm going to increase the sandbags up to 2, means that when I'm going to apply 20 Newton of a force, it took around 2 minutes. Means 120 seconds to cut through, right? 120 seconds. As it is mentioned in as seconds, I have mentioned both the readings, okay? So, it got 120 seconds, 2 minutes, when there are 2 sandbags. So, when there are 3 sandbags, 30 Newton of a force, you could clearly see that it took around 9 seconds, right? So, 9 seconds is our reading. 9 seconds. So, here you can see that there is a dramatical change in it. 2 minutes means that 120 seconds got suddenly changed to just 9 seconds. Just 9 seconds. So, check the gap in here, right? The gap is very, very less right now. Gap is very high, right? Here 120, it's got reduced to 9, means that there is a gap of 111 seconds, right? 111 seconds of a gap. However, the time has got reduced dramatically. Time got reduced. The gap is very high. Okay. Then in the fourth case, when I'm going to apply all 4 sandbags, time got reduced even more up to 2 seconds. Up to 2 seconds. So, my dear children, it's very clear to us from this activity. You can see that 2 minutes 9 seconds, 9 seconds to again 2 seconds means when increase in number of bags or when increase in the amount of force which is on the cake of soap, the cake of soap got separated or cut very quickly. Means when increase in the force acting, the pressure exerted on an object is going to increase. That's why it's getting separated or it's getting dissected into 2 parts very quickly. As I'm inserting more and more sandbags, more and more weights are going to act. Upon having more weights, more force is going to act. If more force is going to act, more pressure is exerted and the time taken will gradually reduce, right? That's the explanation. So, my dear children, it's obvious to us that, it's quite obvious to us that when increasing the force acting or when increasing the force which is provided to a certain surface, the pressure which is getting created also going to increase. Pressure is also going to increase. So, my dear children, we can write our final conclusion from the activity like this. What is that? When increase in force acting when increasing, force acting on a surface when increasing, force acting on a surface, pressure acting on the surface, pressure acting on the surface pressure acting on the surface also increases. It also increases. So when increasing force acting on a surface, pressure acting on the surface also increases. If when increasing the force acting, pressure acting also going to increase. So my dear children, from this activity we can say that, we can conclude that force and pressure, these two quantities are showing a direct relationship. When increasing the force, pressure also increases. When decreasing the force, pressure also decreases. So these two quantities are directly related to each other. When increasing one quantity, the second also increase. When decreasing one quantity, the second quantity also going to decrease. Right? So this is the first and foremost factor that affects the pressure, the force acting on the surface. So when force is going to increase, which is acting on the surface, we can increase the pressure, right? That's why, my dear children, when you apply more force by hanging more sandbags, these soap bars are going to cut very quickly by consuming very less time. Because in each of these instances, when going down, force is going to increase, thereby the pressure exerted is going to increase, thereby more easily these bar of soap will get cut, right? So this is the final conclusion, my dear children. Right then, so now let's head on to see what are our conclusions, special key points that we can take from this activity. We are going to write down what's going to happen, what are the special facts that we can take from the above activity. So accordingly, following facts are revealed by above activity. Now you could see here, when I'm going to conduct the earlier activity, when I'm conducting early activity, you could see that very clearly. When I'm going to increase the force, the tension or the pressure has got increased, and upon decreasing, it got decreased. So first and foremost factor that's going to affect the pressure is the force acting. So force acting on the surface, right? Force acting on the surface is a factor which affects the pressure, right? Is a factor which affects the pressure. Force acting on the surface is a factor which affects the pressure. That's the first and foremost conclusion that we can take. Okay, that's the first and foremost conclusion that we can take from the above activity. Force is directly going to affect with the pressure thing. So we'll write down the first and foremost conclusion then. What is that? Force acting on the surface affects the pressure right? Force acting on the surface affects the pressure. That's the first and foremost thing, or the first and foremost conclusion that we can take from the activity, right? Force acting on the surface affects the pressure. Then how it is going to act, or how it is going to affect, those are the other two points, special points. When force is high, pressure acting is also high, right? When force is greater the force, greater the pressure which is acting. Lesser the force, lesser the pressure which is acting. Okay, those are the other two key points that we got from the above activity. So we'll write down those two. Higher the force, higher the force acting, higher the pressure. Higher the force acting, higher the pressure. Higher the force acting, higher the pressure. Then in the next step, lesser the force acting, lesser the force acting, lesser the pressure. Right. So these are the three main key points or key conclusions that we can take from the above activity. Number one, first and foremost, force is the first factor, right? Or the force acting on a certain surface is the first and foremost factor that's going to affect the pressure. So force acting on the surface affects the pressure. Force acting on the surface, it's going to affect the pressure. Then in the next one, higher the force acting, higher the pressure. Higher the force which is going to act, higher the pressure. Then lesser the force acting, lesser the pressure. Less, if a less force is acting, then the pressure which is going to act, or then the pressure which is going to result is also less. Okay, so these are the three main conclusions that we can take from the activity, my dear children. Now it's time to do another different kind of an activity. Let's see what is that. So once again we are going to study the factors affecting the pressure, but by doing a different activity in here. Okay, right? So in here we'll be using different, right? We'll be using different kinds of wooden planks, right, and a sponge, and with these materials, and we'll be conducting a special kind of an activity in order to show the effect of force. Okay, my dear children, right? So now let's see what are the materials we need. We'll be needing these materials. You'll be needing three wooden blocks, three wooden planks with different lengths and thicknesses. Okay, different lengths and thicknesses. We'll be needing three different wooden planks with three different lengths and three different thicknesses. Right, so these are the dimensions. First, okay, 15 by 10 by 1 cm, then 20 by 15 by 1 cm, okay, then 15 by 10 by 5 cm planks. Right. These are the plank that you will need, okay. So 15 cm, 10 cm and 1 cm plank, 20, 15, 1 cm plank, 15, 10 and 5 cm plank, okay, right. Then you'll be needing a sponge, iron nails, then a ruler or else a scale, The scale is needed to fit on a plank, okay. So, or if you want, you can use a ruler or else a scale. Centimeter scale would be great. Millimeter scale, right? There should be millimeters as well. Then 2 kilogram mass. 2 kilogram mass. Actually, in the textbook, right, they are mentioned to use a 5 kilogram mass in here. But however, instead of using 5 kilogram mass, I'll be using another 1 kilogram of a mass in order to get the total as 3 kilograms. Okay, in order to get the total as 3 kilograms. So, 2 kilogram mass with another 1 kilogram of a mass. So, I'll be writing in here. Here, now you can observe this one is a 5 kilogram of a mass, but however, I'll mention as 1 kilogram of a mass for my convenience. This is for my convenience only, my dear children, right? Because it's difficult to use or to find out 5 kilogram of a mass. So therefore, I have used only 1 kilogram instead of the 5. However, we will be needing 2 different masses. Okay, we'll be needing 2 different masses. That's the case in here. So, I'll mention as 5 kg or a different mass, right? Actually, these things are referred as weights, but it's not convenient to use the term called weight, right? I told you that weight is a factor, right? It's a special kind of a force which is acting towards the ground. Here, 2 kilogram weight is not suitable. That's why I have mentioned in here as a 2 kilogram mass. That's more convenient because from kilograms we measure the mass, not the weight. Weight is a thing called the gravitational pull, right? We measure that thing by Newton. Okay. So if you want, you can mention it like this. 20 Newton weight, then it is correct. Because you know that each 10 kilogram is giving out 10 Newton of a force. So 20 Newton of weight is correct. Okay. Then in here, to fix these things, we'll be needing a hammer for sure. Hammer. Then spring balance to measure the weight. spring balance to measure the weight. Right, my dear children. So, these are the materials that you need in conducting this activity. This is a like a time taking activity. So, we'll be needing several wooden planks. These are the dimensions: 15 by 10 by 1. Then the second one, 20 by 15 by 1. Then in the third one, 15 by 10 by 5. Okay. Then a sponge, some iron nails, a ruler or else a scale, then 2 kilogram mass, 5 or any other different masses, right? Then a hammer, spring balance. These are the materials we'll be needing in conducting this activity, right? Now let's see how to do the activity, right? So it is given in here, materials. So these are the materials you need, okay? So these are the materials which are being fixed in here, right? So you have to fix these materials like this, okay? In each of these figures, it's been arranged, right? Now what do you have to do? Now let's see how to build up these things according to the way we want. So let's discuss what is the method of doing our experiment. Fix planks of the sizes 20 by 15 by 1 and 15 by 10 by 1 cm as shown in the figure A. Right now, we have to fix these materials according to this figure. These two materials, 20 by 15 by 1 plank and 15 by 10 by 1 plank together. Okay, we need to fix these two planks together as in the first one. Place the scale of 15 centimeters along 20 centimeter long vertical side of the plank. Now, according to these figures, you have to place the scale along the 20 side. Okay, right? Along the 20 side, you have to place the scale. Place the piece of sponge on the horizontal plank as shown in the figure B. Note down the reading of the scale which is relevant to the upper horizontal edge of the piece of sponge. Now what do you have to do? We have to place the sponge. Then after that we have to get a reading at the upper top edge of the sponge. Okay. Weigh the wooden block of 15 10 by 5 using the Newton spring balance. Place this wooden block on the piece of sponge as shown in figure C. Note down the new reading as in the second step. Now what do you have to do? You have to take that larger plank. You have to first of all measure the weight of it. Okay, you have to first of all measure the weight of it. Then you have to place that wooden plank on this sponge which is placed at our setup which we prepared by using the materials like in the first case. Okay, so you have to place it over here. Then what you have to do, like in the second step, you have to measure the upper topmost reading. Okay, you have to measure upper topmost reading. You know that when you are going to place this thing on the sponge, definitely the sponge layer, the thickness of the sponge layer will get reduced by some reading. So you have to measure that value. Okay, then what do you have to do? So then what do you have to do? You have to note down the new reading as shown in the second step. Like in the second step, you have to note down the reading, my dear children. Then after that, right? Then after that, what do you have to do? Then place the weight of 2 kilogram on the wooden plank, wooden block as shown in the figure D. Take the reading of the upper edge of the piece of sponge as before. So like in the same way, what do you have to do? Just by keeping the wooden plank in the same way, you have to keep the 2 kilogram weight or 2 kilogram mass above the above the sponge or above the wooden plank which we placed earlier. Then we have to get once again the reading. Okay, then we have to get once again the reading. How much is the reading? Okay, right. So remember here once again they are mentioning as the weight, but however weight thing is somewhat not convenient. I told you that if it is weight then it should be 20 Newton, right? Remember always weight and mass are two different concepts. Mass is the number of particles which is measured from kilograms. Weight is a different factor. Weight means the gravitational pull, right, acting on a certain object, right, acting on a certain object, the gravitational pull which is acting on a certain object. So these two factors are way more different to each other, okay? But however in your textbook it's been mentioned, so I kept the same way, right? So next place the weight of 2 kilogram and the weight of 1 kilogram on the wooden block and take the reading. So it is given that 3 kilogram in total. Tabulate the reading. So I told you that I'm going to use 1 kilogram, another extra 1 kilogram, then 2 and 1 altogether total to be equal with 3 kilograms. Okay. So you have to place 3 kilogram of a weight or 3 kilogram of a mass at the top of the figure over here, right? Then you have to measure how much is the thickness in the or upper reading of the sponge. That's it. So this is the way of conducting the activity, my dear children, by using the materials given. Okay. So once again, what do you have to do? Let me explain once again. You have to take the two planks, fit them together, place the sponge, measure the upper topmost reading by fixing a scale. Measure the other wooden block, measure the weight of it, okay, the larger wooden block. You have to measure the weight of it, place it over the sponge and get the upper topmost reading. Keep the system in the same way, place the 2 kilogram mass on the system, once again get the reading. Keep the system same way, place another 1 kilogram, extra 1 or 2 or whatever the mass you have, place it over the 2 kilogram and measure the upper scale. This is the way of conducting the activity, my dear children. Then finally what do you have to do? Finally, tabulate the readings. You have to tabulate the readings. So according to this table, right, we have to tabulate our readings, my dear children. Okay. So at the first instance, sponge only the sponge. You know that force exerted on the piece of sponge is no, nothing, because we kept only the sponge now. Then reading of the upper scale, you have to get the reading of the upper scale, right? You have to get the reading of the upper scale. There is no reduction in the, right? Then after that, wooden block on the sponge. So you have to measure the wooden block and mention the Newton value in here. Then after that, by placing that thing, how much is the reading you got? Then finally you have to write down the reduction. How much is the answer? Okay. Then like that you have to repeat in each of these instances. When placing 2 kilogram, what's going to happen in each of these instances. Then when placing 5 kilogram, not 5 kilogram, we used how much? 3 kilogram, right? Then when you are placing 3 kilogram, what's going to happen in each of these two instances? So like that way we need to complete the table after doing the experiment, my dear children, after doing the experiment. Okay. So I'll keep the table in the same way. We'll run onto the lab quite fast and we'll conduct the activity. Then once again we'll come back and we'll fill down the table. and let's see what's going to happen. So my dear children, I have prepared the setup right now according to the instructions given, right? So this is the sponge. Now first of all, we'll take the reading on here at the horizontal level of the sponge. So it's around, now if you take the answer, now here the specialty is that we can't get like several centimeter kind of a value. Okay, these values are going to be really sensitive, like up to millimeters. So it's very important to take more sensitive information or more sensitive readings when we are doing this practical or this activity. Let's take the reading to the specific value according to our naked eye. So the value is here, see. So exactly up to millimeter level, it's 5.9 millimeters, right? 1 millimeter less than 1 millimeter less than 6. So in here you can observe the 6 level, level 6, right here. So 1 millimeter less than 6. So it's 5.9 millimeters. This is the initial reading of the sponge. 5.9, my dear children. Okay. Now what I'm going to do is I'm going to take the spring balance, right? So spring balance once again, then I'm going to measure the weight of the spring balance, right? So the weight of the spring balance is now, right? So observe the reading. Here it is at 4.5 newtons, right? 4.5 newtons. 4.5 newtons, my dear children. 4.5 newtons. You can observe it very clearly, right? It's 4.5 newton right now, right? 4.5 newton is the weight of the wooden block. 4.5 newton. Then I have with me 1 kilogram of several weights. I mean, like I have two 500 weights rounded up to 1 kilogram. Then another 2 kilogram of a weight. 2 kilogram one and two 500 grams one to make it 1 kilogram. So instead of 5 kilogram weight, I will be using altogether 3 kilograms, right? So I'll be using 3 kilograms to instead of 5 kilogram here. Now what I'm going to do is I'm going to place the, remember the earlier reading was 5.9. Now I'm going to place the wooden block. So I'm going to place it over here like this, right? So in order to get a good reading, I'm going to keep it very near to the scale over here. Right now I'm going to release it. Now let's take a reading over here. Right now let's take a reading. Okay, so the reading is now, so here you can observe the reading now has got decreased, right? Here the reading has now got decreased. See, it got decreased by 2 millimeters, right? See, the reading got decreased by 2 millimeters. It got decreased by 2 millimeters, my dear children. So now the new reading is 5.7 millimeters. It's 5.7 millimeters. The new reading is now 5.7 millimeters. Earlier it was 5.9, but however now the reading is 5.7, right? 5.7. 5.7 is our new reading. Right then, so what I'm going to do in the next step, I'm going to place the wooden block in the same way. I'm going to use the 2 kilogram mass and place it over the wooden block here. Right, my dear children, now let's take the reading. Now I have placed the 2 kilogram here. Now I'm going to take the reading of the thickness in sponge. So here you can observe, right, here you can observe the reading very clearly. So it's around 5.1. So the reading right now, the thickness is now 5.1, right? 5.1 is the thickness, my dear children. You can clearly observe the 5.1, right? So here, now in here you can observe 5.1. 5.1 can be observed very clearly. 5.1. So when I'm going to place the 2 kilogram, the reading is 5.9, 5.7, now it's 5.1. Okay, 5.9, 5.7, now it's 5.1. By keeping the setup in the same location, in the same place, I'm going to place the 1 kilogram, the extra 1 kilogram weight. Okay, now I'm going to place the extra 1 kilogram weight on this 2 kilogram block, right? Okay, here we go then. Right. So here the final level you can observe, right? So I have placed it. The final level is now up to reduced up to 4.1, 4.1 centimeters, right? So now the thickness level is at 4.1. 4.1, my dear children. The total mass on the wooden block is 3 kilogram, right? 3 kilogram is the total mass on the wooden block. Reading is only 4.1. Thickness is only 4.1 in centimeters. So once again, what are our readings? 5.9, 5.7, 5.1 and finally 4.1. Right. So as you can see here, when I'm going to increase the force acting on the sponge, you can clearly see that the thickness is getting reduced gradually. Right? Thickness is getting reduced gradually. Right then. So my dear children, let's head on to the classroom once again and we'll write down our observations and conclusions. Right, my dear children. So we conducted the activity and we could get these results. First of all, I'm going to complete this one. So the neutral sponge only, it was around 5.9. Then when the wooden block is there, it reduced to 5.7. When I'm going to place 2 kilogram, it reduced to 5.1. Right? When 3 kilogram is there, it reduced to 4.1. Right? So these are the readings that we took from our experiment. Okay. Now I'm going to complete this column. Let's complete. So force exerted on the piece of sponge. Here there was nothing, no force was exerted. So here also there is no change in it. Wooden block on the sponge. So we measured that the wooden block is at 4.5 Newton. It was showing around 450 grams. So 450 grams means 4.5 Newton. Wooden block of 2 kilogram, right? Wooden block and 2 kilogram. Wooden block is 4.5 plus another 20. 2 kilogram means 20. So 24.5 Newton. 24.5 Newton. Wooden block 4.5 Newton. Then 2 kilogram of mass is going to have 20 Newton. Altogether 24.5 Newton. Then wooden block and weight of 3 kilogram. So 3 kilogram is 30 Newton. 30 Newton plus 4.5, altogether 34.5 Newton. Right? 34.5 Newton. So here 5.9 say here 5.7, here 5.1 and here 4.1. Then we are going for the reduction, my dear children. 5.9 to 5.7 reduction is 2 millimeters. I'll cut centimeters in here. 2 millimeters or 0.2 in centimeters, okay? Right? Or else we'll mention both the cases. It's good, no? We'll mention both the cases in here. 0.2 centimeters means 2 millimeters. This is the reduction, 2 millimeters. Wooden block and weight of 2 kilogram on the sponge. So check the reduction. 5.7 to 5.1. 5.7 to 5.1 means, my dear children, we can say 0.6 centimeters, 6 millimeters, 6 millimeters. Then in here, when I am going to apply 34.5 Newton of a force, 5.12, right? 5.1 to 4.1. 5.1 to 4.1. Then, my dear children, the gap is exactly 1 centimeter. 1 centimeter, 10 in millimeters. 10 in millimeters. So these are the observations that we took from the experiment, right? These are the observations that we took from the experiment, my dear children. Right, my dear children. Now these are, by looking at these observations, once again you could clearly observe that when increasing each of these weights from 4.5 to 24.5, 24.5 to 34.5 Newton, thickness of the sponge is also going to reduce dramatically because much tension is exerted on the sponge, right? So therefore much pressure is going to exerted on the sponge, thereby the thickness is going to reduce as it is having a greater pressure. So by using this activity also we can conclude the same points that we studied earlier. The pressure is directly going to depend on the force acting, right? And when increasing the force acting, pressure also increases. When decreasing the force acting, pressure also decreases. This is the final conclusion that we can take from the activity. So let's head on to see the conclusion. So conclusion, we can write number 1, force, right? Force is affecting the pressure created on a surface. Force is affecting the pressure created on a surface. Then number 2, higher the pressure, higher the force, right? Higher the force acting, higher the force acting, higher the pressure. Higher the force acting, higher the pressure. Then number 3, lower the pressure, lower the force, right? Lower the force acting, right? Lower the force acting, lower the pressure, lower the pressure. So my dear children, this is the final conclusion that we can take from the activity. Once again the previous ones, right? Once again we can take the previous conclusions. So force is affecting the pressure created on a surface. Higher the force acting, higher the pressure. Lower the force acting, lower the pressure. These are the conclusions that we can take from the activity. Right then. So my dear children, in every instance of the above activity, the area of the wooden block in contact with the piece of sponge is the same. Yes, in each of those cases, the same wooden plank is placed on the sponge. So therefore, area of the contact surface never got changed. Only factor which got changed is the weight or the force which is acting above. So the force exerted on the piece of sponge is increased gradually. Accordingly, the contraction of the sponge is also increased. It is clear that the pressure on the piece of sponge is increased gradually. Therefore, it can be concluded that pressure increases with the increase of force, right? Pressure increases with the increase of force. In the same way, pressure is going to decrease with the decrease of force. These are the two main conclusions that we can take from these two activities, my dear children. In both the cases, we kept the contact surface constant. However, we increased the force acting. Right then, so we studied the first and foremost factor that affects the pressure. It is, my dear children, the force acting on the surface. When increasing the force acting on the surface, the pressure is high, right? When increasing the force acting on the surface, pressure is high. When decreasing the force acting on the surface, pressure is low. Pressure and force acting are showing a direct relationship. Okay, they are showing a direct relationship. Right then, this is the first and foremost factor that affects the pressure, my dear children. This is about the force. So force is showing a direct relationship with the pressure. Now in the next chapter, we'll be discussing the second factor which is essential or which is going to affect for the pressure. The second factor is the contact surface area. In our next chapter, we'll be discussing these things or the factors or how to investigate by using several activities. How does this contact surface is going to affect for the pressure concept? So I'll hope you to meet with our second chapter to discuss about the surface area.